He's sick and tired of everyone's attitudes.
That was so awkward.
Nice save. You're right. Yeah.
All right, so the first one said find all real solutions. So for this one, this would mirror exactly what you got to do for number one. So what are your options? How do you find the real zeros? Factoring is one option. What else?
Oh, not completing. It's the.
It starts with an I.
No.
Dividing?
Well, dividing doesn't start with an I, but
No, it's I know what
it's synthetic division, which starts with an S.
Yes.
Okay, but synthetic division is another way. What's a third option? Graph it.
Oh, that's the easy.
You could graph it and see where they cross. Okay, now, I'm going to do a little bit of both just to kind of show you what's going on. First of all, if I tried to factor this, it would not factor. Because what times what gives me, if I pull all those pieces out, it ain't going to work. So factoring, unfortunately, would not work the way it's intended or the way the problem is set up. So if I did plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. Those are the numbers that multiply together to give you the constant. Divided by 1, because that's the number, the lead coefficient, would be those numbers. Now, me personally, that's how I start out by doing it. And then after that, what I do is I use the graph and calculator to figure out where do I start. The graph and calculator may give you all three answers. How did I know there was three, by the way? Because the exponent. It may give you all three answers or it may not. If the graph and calculator gives you a bunch of decimal answers or a decimal in your answer, look for the one that's a whole number first. Chances are the decimal was supposed to be a square root of something. So, did anybody graph it to see where it crossed? Where, Courtney? 3? So, if we know that 3 does work, I'm going to synthetic divide that. 1, 3, negative 10, negative 24. And what number should come out if it does work? 1, 6, 8, and 0. Well, 0 should be the end one, right? So if 1 times 3 is 3, 3 plus 3 is 6, 3 times 6 is 18, 18 minus 10 is 8, 3 times 8 is 24, and I get 0. And that's what I wanted to see. Now, since I got one answer that worked and out of 3, that means now that this is 1x squared plus 6x plus 8 equals 0. I can factor that now or use the quadratic formula or complete the square. What times what gives me x squared? What times what gives me 8 but adds up to be 6? 4 and 2. Good. And then when I set each of those groups equal to 0, I get x equals negative 4 and x equals negative 2. And 1, 2, 3 answers I got. Okay? Again, that is a technique on how to find the real zeros of a polynomial. Now, how did we know 3 worked right away? Because I listened to Courtney. How did Courtney get it? Did you randomly try ones or did you actually put it in the calculator?
I just guessed.
Courtney just guessed, which is nothing wrong with that. You could put that equation in the calculator and see where it crosses, and I'm looking at Haley, and it looks like that's what she did. And that's another way to get started. Look and see where it crosses. Okay? What if the calculator gives you all 3 right away? Then I don't have to do the synthetic division stuff or factoring stuff. But I wanted to show you a little bit of it. Okay? If you pick out a wrong number, the end remainder will not be 0. So if I would have picked, let's say, positive 2, the end remainder would not be 0, so then I throw that number away and I start over. Okay, but again, that's like number 1 on your test tomorrow. Then, 23. No, that was 23. 25. Okay, for this particular thing, it's got 1 and then 2 minus root 3. Some of you on Friday were saying it was 1, 2, and then negative root 3. That's not true. The 2 minus root 3 is together. No parentheses in between there. But there is one that is missing. Which number is missing? 2 plus root 3. Remember, the square root or i's should always come in pairs. There should be a plus or a minus. So, from here, now that I have all three pieces, I'm now going to remultiply it back out. Meaning, this would have been x minus 1. This would have been x minus 2 plus root 3. And this would have been x minus 2 minus root 3. And now as far as FOIL goes, does it matter which two you FOIL first? No. But there is a little bit of strategery behind this. Which two would you rather do first? The last two. Why, Josie? Some stuff will go away, right, to make it easier. What's x times x? What's x times negative 2? What's x times negative root 3? Negative x root 3. What's negative 2 times x? What's negative 2 times negative 2? What's negative 2 times negative root 3? Plus 2 root 3. What's root 3 times x? X root 3. What's root 3 times negative 2? Negative 2 root 3. Good. And what is root 3 times negative root 3? What is the square root of 3 times the square root of 3?
It's 9, but then it's 3.
The square root of 9, which is 3. And then there's a one negative there, so it'd be a negative 3. Good. Now when I put everything together, x squared. What's negative 2 minus 2? Negative 4. This goes bye-bye. What's 4 minus 3? 1. And this goes bye-bye. So now it's time to FOIL. What's x times x squared? What's x times negative 4x? What's x times 1? What's negative 1 times x squared? What's negative 1 times negative 4x? And what's negative 1 times 1? Combine like terms, I get x to the third minus 5x squared plus 5x minus 1. And that's 25. $27 is very similar to this. Negative 2, 5, 3 plus root 6. So which one's missing for this one? 3 minus root 6. And then when I put them back in there, the negative 2 becomes x plus 2. The positive 5 becomes x minus 5. X minus 3 minus root 6. X minus 3 plus root 6. This time you have 4 of them. Which 2 do you want to multiply together first? The last 2? Here's a little quick question for you. Does it matter if I do the first 2 and then the last 2? Could I do it that way if I wanted to? When you have 4 of them, it doesn't really matter. Same thing when you had 3. It really didn't matter, but you could do those ones instead if you wanted to. Now, you said the last 2, so let's do those first. What's x times x? What's x times negative 3? What's x times root 6? What's negative 3 times x? What's negative 3 times negative 3? What's negative 3 times root 6? What's negative root 6 times x? What's negative root 6 times negative 3? And then here comes the hard one for most people. What's negative root 6 times positive root 6? Negative 6. Because that would be the square root of 36. And what is the square root of 36? 6. Now, when I combine like terms on that, I get x squared. What's negative 3 minus 3? Negative 6. That cancels. What's 9 minus 6? 3. And then this cancels. Now I'm going to do the front 2 instead of doing it by one group and then another group. So front group goes by way faster. What's x times x? What's x times negative 5? What's 2 times x? And what's 2 times negative 5? And when I combine like terms, I get x squared minus 3x plus, or minus 10. Okay? So what I've done, I multiplied the first 2, I multiplied the last 2. Now I'm going to take their answers and do what? Multiply them too. What's x squared times x squared? What's x squared times negative 6x? What's x squared times 3? What's negative 3x times x squared?
What did you just say?
What's negative 3x times negative 6x?
18x squared.
What's negative 3x times 3? What's negative 10 times x squared? Negative 10 times negative 6x. And negative 10 times 3? Combine like terms, I get x to the 4th minus 9x to the 3rd. What's 3 plus 18 minus 10? What is negative 9 plus 60?
Negative 9 plus 60 would be 51.
Good job.
I'm proud of you. You got this today.
And that's 27.
Oh, no. Really? I got 14. I fell asleep at 6.
$29. 29.
Oh, and then they thought it was going to slow down. Everybody that was there after 6 bought 2 more hours.
Hey, which one's missing? 1 minus 2i. And then I got x minus 3. X minus 1 minus 2i. X minus 1 plus 2i. Quick question for you. What's the difference between this and the previous 2?
This one has imaginary numbers.
This has i's. Right, imaginary numbers. The other ones didn't. Okay? Which two do you want to multiply together first? What's x times x? X times negative 1? X times 2i. Negative 1 times x. Negative 1 times negative 1. Negative 1 times 2i. Negative 2i times x. Negative 2i times negative 1. And what's negative 2i times positive 2i? Negative 4i squared. What was I squared though? So two negatives would make that a positive 4. 2 times 2 is 4. Combine like terms. Those cancel. Okay, now what? What's x times x squared? What's x times negative 2x? What's x times 5? What's negative 3 times x squared? What's negative 3 times negative 2x? And negative 3 times 5. Combine like terms. Minus 5x squared plus 11x minus 15. Again, the difference, as per Vanessa and Devin said, between the first two that we did and this one, the other two just had square root. This has i's. It's the only difference. Okay? And that's number 29. (31) has negative 5, negative 4, 1 minus I root 3. So which one's missing? 1 plus I root 3. Yep. So x plus 4 or 5, x plus 4, x minus 1 plus I root 3, x minus 1 minus I root 3. Now, again, just to kind of remind you, a lot of you were messing this one up and you were wondering on Friday, why wasn't it canceling? The ones didn't change. They're both the same. It's the i's where one's positive and one's negative, not the number. It's the I piece that has to have one of each.
Oh, that makes sense.
Okay?
So the sign in front of I you changed?
Yes. If I FOIL the first two, just to save us some time, I got x squared plus 9x plus 20.
I thought we were going to do it together.
Because 4x and 5x makes 9x.
Yeah.
Now, what's x times x?
X squared. I'm going to get this one.
What's x times negative 1?
Negative x.
What's x times negative I root 3?
Negative I root 3x.
Negative I root 3x. Good.
I got that.
What's negative 1 times x?
Negative x.
Negative 1 times negative 1?
1.
Negative 1 times negative I root 3.
Negative. Wait, what?
Negative and a negative would make it a positive.
Oh, okay.
What is I root 3 times x?
I root 3.
What is I root 3 times negative 1? Now here comes everybody's Achilles heel. What's negative I root 3 times positive I root 3? 3.
Because you take out.
Negative, or first of all, a negative I squared. I squared is negative itself. Two negatives make that a positive. And then root 3 times root 3 is root 9 or 3. When I combine like terms, I get that, because those cancel. Now what? X squared times x squared. X squared times negative 2x. And x squared times 4. 9x times x to the third. 9x times x, or negative 2x. And 9x times 4. Twenty times x squared. Minus 2x times 20. And 20 times 4. So if I combine all my like terms, I get x to the fourth. What's 9 minus 2? What's 4 minus 18 plus 20?
Oh, okay, so that's, yep.
What's 36 minus 40?
4.
Okay, now, just to point this out to you, we just did 4 of those. Remember what I said? 2 and 3 were on the test.
Yeah.
Okay, now look at what we did. We did 2 with eyes and 2 without eyes, and there's 2 on the test. If we did 4 of those, 2 with eyes and 2 without eyes, and there's 2 on the test, what do you think happened?
One of each.
Well, maybe. That'd be probably a smart idea
Okay.
to do 1 with eyes and 1 without. But we'll see.
Wait, it was negative 4x plus, I was listening, 80. No, it's minus 80. It's not minus 80.
Okay,
Is it?
number 4 on your test looks like number 33. It says, how many of each type of solutions could you have? First and foremost, how many solutions are there total? 4. How'd you get that? I asked X one. Then, in order to figure out if you have how many of each positive, negative, or imag you have,
You look at the
sign changes. Good. Does it change signs? How about now? How about now? How about now? So how many sign changes did it go through? 1. That means that I can only have 1 positive solution. Can I subtract 2 away from 1? No. I got to keep it as a 1. I can't change that. Now, as far as the rest of this goes, to get the negatives, if I put negative x in there, you put negative x in for all the x's, and that will tell you how many negative ones we could have. A negative 4 times plus 1 in the front makes how many negatives? 5, which would be negative still. A negative here 3 times plus 1 there is 4 times, which means a plus. A negative 2 times makes that a plus. A negative 1 time makes that a negative, and that has nothing to change it. How many sign changes do we have here? 1, 2, 3. Which, just as you guys have that idea, if you're supposed to have 4 and you know 1's positive, common sense should tell me that I could have 3 negatives, right? Because 1 plus 3 makes 4.
Yeah.
Now, can I take any away from the positives? No, because if I did, I'd be in the negative numbers. Can I take away from the negatives? Yeah. If that number is 2 or higher, you can take it away. And what I mean by taking away is I take away pairs of numbers because I got to pick up the imaginary ones. If I had 3 to begin with and take 2 away, how many would I have? 1. So where would those extra 2 go?
In the imaginary.
And in the imaginary column. And that is my only option I have. I cannot take any more away because if I did, I'd be negative number of solutions, and that's not possible. So as far as that one goes for 33, that's your answer. You have to do that for one problem. It's number 4 on your test.
Or if you
Or one like it.
take 2 away.
Because it always, imaginaries always come in pairs.
Oh, okay.
It's either going to be 0, 2, 4, 6, 8, 10, or how many?
Is that why we make, on the other ones that we just did, we had to have one a positive and one a negative?
Yep. Okay, then 35.
We connect the dots on that, so thank you.
35 has f of x equals x to the 4th. G of x equals negative x plus 9 to the 4th. On number 5 on your test, it says, describe the transformations that take place, and then sketch each graph. Let me read these directions. Describe the transformation of f represented by g, then graph each function. Same. So, what transformations occurred? I heard left 9 and reflection over x. Those are the only 2 transformations that took place for this one. The reflection because it's on the outside and it's a minus, and the left 9 because it's an adding on the inside. Is that new? No. You've had what, at least 3 other times you've had to do that? Or if not more? And we're not done. There's more transformations still coming. Okay? Different parents. As far as the graphing, did you notice that it said graph each? What does it mean by graph each? Put both of them on your graph. So the first one, when I type it in my calculator, it looks something like this. Then the other one, 1, 2, 3, 4, 5, 6, 7, 8, 9, looks something like this. According to what you guys told me for the transformations, I shifted it to the left 9, and I reflected it. Is that what you guys saw on your calculator? I'm guessing that you probably typed it in the calculator to get the picture, and there's nothing wrong with that. Are you okay with doing that? That's like number 5 on your test. Then, number 37 says, write the rule for G. This is like number 6. Here's the original function. And the first thing that it says is, translate it 5 units up. What does 5 units up do? Plus 5. Where? Outside of the parentheses, which there isn't one, so I can just put plus 5 there and that's okay. What's negative 12 plus 5? Negative 7. So I have this so far. Then it also went on to say, followed by a reflection in the y-axis. X-axis was on the outside. Y-axis is on the... Is there a parentheses right now? No. So you need to make them. Where do you make them? Where the x's are. So you put it in parentheses. You put it in parentheses. Every place there was an x, I put negative x in parentheses in its place. Now, as far as I'm concerned, this is okay if you leave the answer like this. Another way that you could also do that is you could simplify it. A negative 4 times is x to the 4th. A negative 3 times with a negative in the front makes that positive 2x to the 3rd minus 7. Either way, that is the same answer. Are you guys okay with writing the rule? That's number 6, or the one like number 6. Then on 39, it says graph the function. So we've got x to the 4th plus 3x to the 3rd minus 8x squared minus 8x plus 2. And the first thing it wants you to do is graph the function. So if I graph my function, I think it comes in here, does this number, and then goes back up. I am just assuming. So if you type that in, you sketch what you see. And I think that's what I see. Did I get it right? Or close to it? Okay, so at this point, then it also asks you to identify the X-intercepts. How many X-intercepts are there? 2. What are X-intercepts also referred to as? Zeros. You said there was 2 of them. So, in order to find the zeros using the calculator, the first one's right here. So if it's coming downhill, left bound needs to be above the line, right bound needs to be below the line. Guess? Nope. Just tell me the answer. And I get an answer of, if I remember right, 0.24. 0.25? Then, when it's going up the hill, left bound needs to be below the x-axis, right bound needs to be above the x-axis. Guess? Nope. Tell me the answer. And what did we get? What's the other one? Say it again. Thanks, Devin. 1.34 and 0. So you found the x-intercepts. Awesome. Now, the second thing that it asks you to do is identify any local minimums or maximums. How many minimums are there? 2. How many maximums are there? 1. This is a minimum, and this is a minimum. This little nub right there is a maximum. Now, in order to find those, what buttons do you push on your calculator again? Second trace, option 3 and 4, minimum and maximum. The first minimum on the left, does anybody know what it is? This is where you should have already probably typed this in the calculator and got the answer like maybe Friday or over the weekend. I actually did it. And if you look at that one when it was negative 1.9999, whatever, like that, that's because of pixels. That's really negative 2. Okay. What about the other minimum? Again, when you do minimums, just so that you guys remember this, left bound on this side of the hump, right bound on the other side of the hump. Guess? Nope. Just tell me the answer, and I'll give it to you. 0.88 and 3 point what? Negative 3.17, right? Okay. Thanks, Devin. As far as the max goes, left of the hump, then right of the hump, and then hit enter twice, because it doesn't really matter if you guess. What is the maximum for that? 7.06. Okay, thanks, Devin. Now, right now, what we've done is we've graphed it. We found the x-intercepts, and we found the minimums and maximums. And for the most part, you guys have been pretty good with those, at least. Now, as far as the increasing and decreasing load, this is the part where some of you are struggling. Increase versus decrease. Now, first and foremost, the bad thing about increasing and decreasing is there's more than one way to write it. And that's where I think some of you guys are getting confused. Which way do you write it? Honestly, I don't care. So, do you want me to do interval notation, which is like parentheses and U's? Or would you rather me write it as inequality symbols like less than or greater than? Okay. So if I'm coming down the hill, am I increasing or decreasing to start? I'm decreasing left of negative 2. Where did I get the negative 2 from? The minimum, because that was the first point that made any difference. Then from that minimum to that maximum, what are you doing? Increasing. So from -2 to where was the maximum's x-coordinate? -1.13. Then at -1.13, or this max, to this min, what's going on? We're decreasing. So from -1.13 to that minimum's x-coordinate. What's the x-coordinate of the minimum? 0.88. And then from this minimum to infinity and beyond, it's doing what? Increasing. So that's x is greater than 0.88. That is, if you're going to use inequality symbols, that's how you would write it. If you're going to use the interval notation, it would look a little different. Interval notation would look like something like this. -infinity to -2 with a parenthesis. And -1.15 or 13 to 0.88 with a parenthesis. This one would be -2 to -1.13 with a parenthesis, then a union, and then 0.88 to infinity. That's how they would look if you're using interval notation. Does it matter to me which one you have? No. You decide. I'm not going to make that decision for you. You be responsible for that. Then the last part that's going to have you doing on number 7 is it's going to ask you whether it's even, odd, or neither, which you did not have to do on 39, but you did have to do on 41. When you're deciding whether a function is even, odd, or neither, again, what you do is you take the x out and replace it with what? I take the x out and replace it with x with a -x. And then I simplify it. What's -x times -x times 3? Now, here's how you know. If the problem simplifies back to the original problem, it's even. If all the signs change, it's odd. And if it does a little bit of both, that's neither. So what did this do? It stayed the same, so therefore it's even. And again, if it's not even and it's not odd, then what's the other option? Neither. So on number 7, on your test again, you will be asked to first graph it. Second, come up with the zeros or x-intercepts. Third, min and max. 4, intervals are increasing and decreasing. 5, even, odd, or neither. That's what you'll be asked to do for number 7. Then number 8 says, use technology to come up with the equation, which is what 43 asks you to do too. So when I'm giving you a bunch of ordered pairs like that, like they say -4, 0, 4, 0, 0, 6, and 2, 0, what do? How do you come up with the equation? How do I use my graphing calculator to do this for me? I hit stat, and then edit. L1 is for x's, L2 is for y's. Then stat again. Over to calc. And on number 43, it specifically asked you for cubic. But what if it doesn't specify? Then you go to either number 6 or 7, which is cubic or quartic, and you see which one gives you the best r squared value. What's the best r squared value there is? 1 or -1, and actually, because it's squared, it'll probably only be a 1. So what equation did you come up with for 43? For those of you who actually did it. 0.19 x to the third 8x squared plus 6. Again, number 1 says find all real zeros, just like number 23 did for your assignment. Then 2 and 3 say write the equation, which is exactly what 25, 27, 29, and 31 did. Number 4 on your test says determine the number of solutions, which is exactly what 33 did. Number 5 says describe the transformations and sketch each graph, exactly like 35, I think. Yep. Number 6 says write the rule, which is just like 37. 7 says graph it, identify the x-intercepts, mins and maxes, increasing, decreasing, even and odd, which is like 39 and 41. And then number 8, use technology to come up with the best equation, just like we did for 43. If you want to hang on to your